this lesson today is taking things that you already know how to do. So remember when we talked at the very beginning of the term, I said Algebra 2 is just Algebra 1 taking it up a notch, right? So today's lesson is doing things that you already know how to do, and that is factoring. Okay, so again, remember when we started factoring, I said you're going to use it for the entire term that you're here. So when we are looking at these types of problems, we actually have already done a couple of them when we were practicing for AccuPlacer. And so we're going to start this lesson. This is 4.2b. Okay, so you're going to label this 4.2b. And it is simplifying rational expressions. Simplifying rational expressions. Yesterday we did simplifying rational exponents. But now we're going to talk about the entire expressions, and I'm abbreviating expressions. Okay, I know that's not how you spell it, but I'm going to abbreviate that. And then it says you will be using the factoring techniques you have just learned in the last 4 weeks to simplify fractions involving algebraic expressions. If you follow these 3 steps, I'm a step person. I like you to tell me what do I need to do first, what's next, and then how do I finish it. Okay? So these 3 steps are going to help you to make sure you always get the right answer. If you start to cancel before you have factored, you're not going to get the right answer. Okay? So the first thing we always do is factor completely both the numerator and the denominator. So if we're looking at example 1 here, in the numerator, 9x plus 3, what is something I can factor out? What's the greatest common factor here? Mitchell? 3. And Mitchell, what does that leave me with if I pull a 3 out?
3x plus 1.
3x plus 1. Okay? In the denominator, what can I pull out of the denominator? 4. Daniel, what does that leave me with if I pull out a 4?
3x
Plus 1. All right, so if I'm looking at my steps, it says number 1, factor. We did that. Step number 2 is to cancel like factors. They have to be exactly alike. All right? So 3x plus 1 and 3x plus 1 are exactly the same thing. So I am allowed to cancel 3x plus 1 and 3x plus 1. And when I cancel them, I'm left with just 3 over 4. That's it. Dalton?
So you can cancel them even when they're the same sign? They don't have to be a plus and a minus?
If they're plus and minus, they're not the same thing, right? So you can't cancel them if they're not the same thing. So they have to be exactly the same. All right? Number 2 says factor, again, the entire numerator and factor the denominator. Olivia, what is x squared minus 9 factor to? What do you notice about both of those things? Okay, so what are you going to factor that to? I can't hear you. X minus 3 and x what? X minus 3, and then the other one is x plus 3. Good. Okay, what about the denominator, Crystal? What do they have in common in the denominator?
5.
5, and what does that leave you with, Crystal?
X plus 3.
Good. My like factor is what, John? What's my like factor?
X plus 3?
The entire x plus 3. So then I'm left with, on the top, x minus 3. And on the in the denominator, I'm left with just 5. Now, in the numerator, you can put parentheses around it or not. It's not going to change the answer. Okay? Questions on number 1 or number 2?
What did you say in the numerator? Are we not allowed to do that in the denominator?
What, parentheses? Oh, I mean, yeah, if it happens, you can. It wasn't on this example. All right, let's look at example 3 then. Okay, so in example 3, we have a trinomial. How do we factor a trinomial? First of all, we always look for what? The greatest common factor. Dalton, is there a greatest common factor in the numerator?
No.
No. So then what are you going to do next?
X.
Excellent. You're going to X factor. So off to the side here where I have room. What two numbers multiply to get 5 and add to get 6? Do 3 and 2 add to get 6?
Oh no, I wrote it backwards.
5 and 1, right? Now, are we allowed to take the shortcut here and just set up our x's?
Yeah.
We can because the coefficient is just 1, right? So in the numerator I have x plus 5. And I have x plus 1. Are we okay so far? Now I'm looking in the denominator. Is there a greatest common factor in the denominator, Braxton?
No.
No? Okay, so what do you do next? Okay, so what two numbers multiply to get negative 2 and add to get a negative 1? What factors are you going to choose, Ashley? Positive 2 and positive 1? What two numbers multiply to get negative 2 and add to get a negative 1? Which one needs to be negative, the 2 or the 1? Right, so that when you add together you get a negative 1. Okay? So I can set up my parentheses again. X plus 1, x minus 2. Now, it doesn't matter, we can see that x plus 1 is the same on top and bottom, but does it matter that one's over on the right side and one's on the left side?
No.
It doesn't, right? It's the same number. Yeah, you could have written it differently, correct. So I can cancel my x plus 1 and my x plus 1, which leaves me with x plus 5 over x minus 2. Now, can I cancel x over x? But they're the same.
But they're not really
Connected.
Good. They're connected, right? They're connected with that 5 and it's connected with that negative 2. So I have to leave it as is. So this is going to be my final answer. Questions about that one?
Would it be possible to reduce that further?
What would you reduce by?
Valid point. I just reduced something more advanced.
You cannot reduce that. We will, by factoring, you are reducing. Okay, number 4. If you look at the numerator, it says there's a GCF in the numerator, right? So what's my GCF, Aspen?
3.
3. And what does that leave you with in the numerator, Aspen?
In parentheses with 3 on the outside, x squared plus x minus 6.
Good. What about in the denominator? Is there a GCF in the denominator, Cedric? Okay, so I'm just going to rewrite the denominator, 2x squared plus 5x minus 3. Now guys, I am leaving plenty of room over here for me to continue writing my answer out, okay? So use this space down here to do your work, all right? Don't confuse and put all your stuff in here and then try to figure out which ones you have left. Use this space down here to do your work, okay? So if I'm looking at the first one, x squared minus x minus, or plus x minus 6. So what two numbers multiply to get negative 6 and add to get a positive 1? Samantha, what factors are you going to choose there? Multiply to get negative 6 and add to get positive 1.
6.
Okay, 6 and 1 do make 6, but do they add to get 1?
3 and 2.
Perfect. Which one needs to be negative so that you get a positive 1?
2.
Good, the 2.
Oh no, we're doing
I'm doing the top one. I'm doing the numerator. Okay. Keep it straight. So then I know that I'm going to use in the numerator 3 times x plus 3, x minus 2. So when I simplify things, I keep it still up here by the problem. Okay. Now, how are we going to factor the denominator? Who wants to tell me how we factor the denominator?
X factor.
Okay, we are going to x factor, but we have to remember to do what? multiply your first times the last, right? So 2 times negative 3 is negative 6. And they have to add to get 5. What two numbers multiply to get negative 6 and add to get 5? 6 and 1, which one needs to be negative? The 1. Now, I'm going to rewrite this down here, 2x squared plus 5x minus 3. Am I allowed to just write my parentheses? No, this is a what kind of problem? What do I have to do now? Because I can't just write x minus 1, x plus 6. What'd you say? Aspen's reminding us we have to split the middle, right? 2x squared comes down. We're splitting the 5x between the negative x and the positive 6x. You know how to do this now. Do it on your own paper. I'm getting 2x minus 1 and x plus 3. Is that what you guys are getting? Anybody not get that? Okay, Ben, what am I going to cancel? Okay, we're going to cancel x plus 3 and x plus 3. So then what's left on the top is 3 times x minus 2. And what about the denominator? What's left there? Just 2x minus 1. That's it. Anyone have questions on how I got here? Are we okay with this? It's just factoring, right? Factoring and cancel. Factoring and cancel. I told you you'd be doing this forever. All right, let's go to the next page. Let's do a couple more examples. Why don't you try number 5 on your own?
What do you mean by excluded values?
We don't have to worry about the excluded values right now. Oh, come on. Okay. Did anyone do this? What is our very first step? Taylor?
Factor.
Factor. Did you factor the top first?
Yeah, I did.
You did?
That was my second step.
Okay. So the first step, if you did that, it would be incorrect. So for the first step is to factor the 5, which leaves me with a minus 2. Factor the denominator. Well, that can't be factored, right? It's just 5.
Cancel the 5.
And now you can cancel the 5s, yes.
And then your answer is a minus 2.
That's it.
Man, I had that with our reason because she marked out the 5, so I never thought it was wrong. And she tried to pull it fast before us.
Okay, try number 6 on your own, please. And check with your neighbor when you get done. Okay, Alyssa, what did you factor out of the numerator? 2 what? 2y, okay? So in the numerator we pull out a 2y, which leaves us with y plus 4. Brooklyn, what about the denominator? What does that factor to? Did you say I don't know?
Yeah.
Okay. Are they both perfect squares?
Yeah.
What's the square root of y? I'm sorry, what's the square root of y squared? Just y, right? What's the square root of 4? I mean 16. 4. And then what do you have to remember about the signs here, Brooklyn? Right, one has to be plus, one has to be minus. Okay? All right, Crystal, what are you going to cancel?
The y plus 4.
All right, y plus 4 is gone, y plus 4 is gone. Ryan, what are we left with?
2y is the numerator and 1 minus 4 for the denominator.
Perfect. Raise your hand if this is what you have on your paper. Excellent. Any questions about number 6? We're moving right along. All right, number 7. Okay, let's factor the top first. Go ahead and factor the numerator. Factor the numerator. You know how to do that one.
Is the cube a special snowflake?
No. Right here. Okay, did you guys get x minus 2 and x minus 4 on the top? Alright. So then, in the bottom, it's a sum or difference of cubes. How did you know it's difference, Aspen? Because it's a subtraction problem, right? So, again, we're going to save some room there to write our final answer. Let's write it down here so we can show our work. X cubed minus 8. Let's go ahead and write our formula. We know that it's a minus b times a squared plus ab plus b squared. Okay, so why don't you see if you can factor that using, we just took a test over this, sum and difference of cubes. Find your a, find your b. So the square root of x cubed, I'm sorry, the cube root of x cubed is x. The cube root of 8 is what? 2. So that becomes your a and your b. The a value squared is going to be x squared. A times b, so 2 times x is 2x, but it's a plus. And then our b value squared, 2 squared is 4. So that whole thing becomes my denominator. So I have x minus 2, x squared plus 2x plus 4. Donald, what do they have in common? What are you going to cancel out?
X minus 2.
Good. X minus 2 and x minus 2 is gone. So we are just left with x minus 4 over x squared plus 2x plus 4. Dalton, can I cancel these two 4s out?
No,
Why not?
they're opposite signs.
Okay, if they were the same sign, could I cancel them out?
Yeah.
No.
Why am I not allowed to cancel them out, Leanna?
Because that bottom 4, well, they're both connected to everything else.
Remember, Dalton, these go together, right? They're one big number. Don't get tricked. Don't get tricked.
Although I do have one question about that. I thought that, that the plus or minus signs, multiplication signs, whatever, separate them as terms.
They are separate terms, but they represent one number, right? If you knew what x was, like if you knew that x was 7, and you did 7 minus 3, this number would just become 3 by itself, right? It represents one number. Even though it's two terms, it represents one whole number.
Okay, so as long as variables are involved, it's
Yeah.
considered one whole
Correct.
number.
Correct. Mitchell?
Can you factor out the x squared plus 2x?
Okay, so that's a good question. Mitchell said, can we factor out x squared plus 2x plus 4? If we tried to factor that out, okay, if I tried to factor that out, what two numbers multiply to get 4 and add to get 2? Multiply to get 4 is 1 and 4 or 2 and 2. Do either of those add together to get 2? No. So here's the thing. When it's coming from a sum or difference of cubes, okay, that's it. It's fully factored because the formula gives us fully factored. All right? So if it's coming from the sum or difference of cubes formula, it's already all the way factored. That's a good question, Mitchell. All right. We okay with this stuff, right? Ready to move on? Good. I'm glad you agree. Okay, let's go on to the second half of this example.
You were gonna move on whether you're ready or not. weren't you?
Oh, let's look back at number 6 real quick. Okay, it talks out there, it says excluded values, right? So if something is an excluded value, this is what it means. If we're looking at example 6, what number in here for y would make the denominator be 0? Positive 4, right? If you plugged a positive 4 in for y, 4 minus 4 would give you 0, right? So what an excluded value is saying y cannot be 4. Because if we get a 0 in the denominator, you can't divide anything by 0. Like if you do that in your calculator, you get error. So the excluded values are what numbers are going to make your denominator only, we don't care about the numerator, make your denominator become 0. So in this example, our excluded value is 4. So you'd say y cannot be equal to 4. That would be the excluded value.
So the equal sign with a slash through it is
Not equal to. Makes sense, right?
It does, but it's a symbol I don't see very often.
You're right. Welcome to Algebra 2. All right. Moving on down. Okay, so now that we have simplified them, now we're going to add and subtract. Okay, so when we are no, that's tomorrow, just kidding. Maybe later today. We're going to multiply and divide. Okay? So it says multiplication and division follow the same factoring techniques. Okay? As if we were just doing what we just did, okay, which was simplifying. So here's the thing. If you look at problems steps 2, 3, and 4, it's exactly the same as what we have been doing. The only difference is it says if it's division, rewrite the problem as multiplication of the reciprocal of the second expression.
I was actually going to do that
Hang
before
on. So what this means is this. Let's write a really basic example, guys. If I say 2/3 divided by 1/4, write that over there on your paper. Do you guys remember dividing fractions is the same thing as multiplying by the reciprocal? Do you guys remember that? So what you're going to do is you're going to leave 2/3 the same. We change the division sign to be multiplication. And then we flip, which is called the reciprocal, 4/1, the second one. Okay? So anytime a fraction is a division problem, You change it to multiplication, and you flip just the second fraction. The first one stays the same. So if we look at example 8 here, I have 8 minus k over k squared minus 64, so that one stays the same. Instead of doing this, because that irritates the heck out of me, we're not going to do that. You're going to rewrite it. All right? So you're not just going to change the problem in there because you're going to mess up. All right? So we're going to rewrite the problem. 8 minus k. Can we go ahead and factor that denominator? What does k squared minus 64 get factored to? K plus 8, k minus 8. Go ahead and factor that.
Are we allowed to do that?
Yep. You're just cutting out one step. And then we're changing this to times, and we're using a dot instead of the x to make times, because we're in algebra 2 now. And then I flip the second fraction, so now k plus 8 goes on top, and k minus 8 goes on the bottom. So let's recall back really quickly to basic math. If you have 2/3 times 6/4, do you guys remember you can do this? Do you remember doing that? Cross canceling, okay? What you can do is you can go across diagonally and cancel. All right, so if we look at this example, I have a k plus 8 here and a k plus 8 up here. I can cancel them out, because if I were to multiply them straight across, eventually they would both be on top of each other, right? If I just multiplied everything across, eventually they would be on top and bottom. So instead of doing that and wasting time, I'm going to go ahead and cancel k plus 8 with k plus 8. So you can cancel up and down on top of each other, diagonally, but what you can't cancel is this. I cannot cancel this k minus 8 and this k minus 8, okay, because they're on the same level. Can't cancel the same level, all right? So, does anything else look like it could be canceled? Okay, 8 minus k, is that exactly the same as k minus 8?
No, because if you look at your
Yeah.
8, there's negative.
This 8 is positive, this 8 is negative. This k is negative, this k is positive. So when something like this happens, if I divide, so bear with me because this is going to be new to you, okay? If I divide this one by a -1, or if I pull a -1 out, okay? If I pull a -1 out, what does that do to the two signs? It makes this a -8 and makes this a what? Positive k. Okay, did you see what happened there? If I divide by a -1, which you are allowed to do, if I pull out a -1, that changes this 8 to be negative and this k to be positive.
But that changes the problem, though.
It does change the problem, but because I have the -1 in front, it's still meaning the same thing. It's like this. Instead of writing 2 plus 3 is 5, you're writing 4 plus 1 is 5. It's the same thing. They both equal 5. You just wrote them differently.
I feel like they should just make these things up as they went along.
Okay, well,
Seriously.
you can think that, but that's the truth. Okay, so now I have a positive k and a -8. So now what do you do? I can cancel, right? This one, well, I can erase it out if I want to. This one with either one on the bottom, it doesn't matter, but only one of them. Okay? So now what's the only thing left in the numerator? It's gone. There is no k in the numerator. -1 in the numerator is left. And then what's in the denominator? K minus 8. You don't have very many with that -1. That one's kind of a trick thing. Okay? All right, so let's look at number 9. Is it a division problem? So what do we need to do? We need to flip it. So the first thing I'm going to do is rewrite. So I'm going to rewrite the first one. K plus 1 over k minus 3. Change it to times. Now, let's go ahead and factor the denominator. K squared minus 1 is going to factor to what?
Okay.
What, Dalton?
Okay.
Just K?
No.
Do you have perfect squares? K squared minus 1? Becomes what? K plus 1,
K minus 1.
K minus 1. It's in the bottom now, right? Because we flipped it. And then what are we going to have to do with that K squared minus 4K plus 3? We're going to have to what? X factor off to the side. Okay? So what two numbers multiply to get 3 and add to get a negative 4? What two numbers multiply to get 3 and add to get a negative 4? Ben? I'm sorry, I can't hear you when you're mumbling. What did you say? -3 and -1. Okay? So, because it's just K, the coefficient's 1, I can write this as K minus 1, K minus 3. All right, any questions so far? We're okay? Get it? We're okay? Thank you, Daniel. Okay, Taylor, what's one thing I can cancel?
You can cancel the K minus 1.
All right.
Minus 1.
K minus 1 and K minus 1. Cedric, what else can I cancel? K minus 3. K minus 3. Kate, is there anything else I can cancel? I said Cade. Is there anything else I can cancel, do you think? You can cancel K plus 1 and K plus 1.
This would be big for 0, isn't it?
What is anything divided by itself?
1.
Not 0. So this whole answer just reduces to 1.
I swear that's running down with mathematicians.
All right. We're going to do just, I think, one more maybe on the back. Maybe 2.
I'm serious.
All right. I would like you to try number 11, please. Try number 11, please, on your own. Factor numerator and denominator. It's already multiplication, so do we need to flip it? No. Okay. So go ahead with number 11. If you're watching the video, go ahead and pause and try number 11. Okay, Daniel, what's something you're gonna cancel out?
Cancel out D plus 3.
D plus 3. All right. Ashley, what's another thing you're gonna cancel? D plus 2. Lexi, what else are you gonna cancel? Say that louder. There is nothing else to cancel, right? You cannot cancel D plus 1 and D minus 1 because they're not the same thing. So in the numerator, I'm left with a 2 and the D plus 1. So I'm going to write that once. 2 times D plus 1. And in the denominator, I'm left with a D minus 1.
I really thought at first that it was one of those ones where you times it by a negative, but when I did it, it changed the D to a negative.
Yeah. So the trick to figure out if you're supposed to divide by negative is if the variable is negative. Okay. All right. Did anyone get this right before I wrote the answer up?
No, I'm still factoring the
A few of you?
I threw out my 2.
Okay. Guys, this is not a new concept, right? You've been factoring for the last 4 weeks. So this is not a new concept. You just have to keep it straight. And on your homework, there's plenty of space for you to write, and I've lined it out for you. Okay? Our last one we're going to do is number 13. So let's scroll down to number 13. Well, you can just move down. I'll scroll down. Okay. The first thing, is it multiplication or division? So do we need to flip anything? All right, so here's my hint. In your homework, I would go through and circle the division problems, all of them in your homework today, So that you remember right off the bat that you need to do that, to flip them. Not right this second, Mitchell, in a few minutes. Okay, so the first one doesn't need to be factored. That 5 just stays as is. So now we're going to see, okay, I need to see what numbers multiply to get negative 30 and add to get 1. Crystal, what multiplies to get negative 30 and adds to get 1?
29 times negative 1.
29 times 1 is 29, right? What multiplies to get 30?
30 times negative 1.
Okay, but when you add there, you get 29. What else makes 30? 5 and what?
5 and 6.
Okay, which one needs to be negative so that I get a positive 1?
The 5 needs to be negative.
Good. Okay, so then this is going to be x minus 5 and x plus 6. Over times here. How are you going to factor that second numerator? The GCF. John, what is the GCF?
GCF is 7x squared.
7x squared, okay? 7x squared, which leaves me with x minus 5, right? And then I have a 7x squared on the bottom. All right, Donald, what are you going to cancel?
7x.
7x squared?
Yeah.
Okay, Mitchell, what else are you going to cancel?
I cancel out the x minus 5.
Okay. Brooklyn, what else are we going to cancel? There is nothing else, right? So what's left in the numerator, Brooklyn? What did you say? Just the 5? Okay. Left in my denominator, Daniel?
X plus 6.
X plus 6.
Honestly, I figured this would be a lot harder.
Finished. Questions on this?
Yeah, why did you think you do a factoring problem?
Because I knew you love it. All right, let's look at our homework real quick. You need to do 1 through, how many problems are there? You need to do all of them. So 1 through 14? Okay, you need to do 1 through 14. All right? So I would take a minute and look through the first page is just factoring and canceling. The second page is when we have the multiplication and division. So on the second page, I would find the ones that are division and circle those so that I remember to switch them. Okay?